gonna still.
Okay, just don't move it from that position.
But
Kind of like see where the lines are here. Just keep it in
keep
there.
going that light. Okay.
Yeah, the center line's about the center.
So what are you doing here, Doug?
So I'm putting coffee creamer into our medium. And so this is actually supposed to imitate or illustrate what goes on with why the sky is blue. So here, so in the real atmosphere, in the real sky, basically you have scattering off nitrogen molecules, nitrogen gas, and basically the atmosphere. So we don't have the luxury of having like miles and miles of atmosphere, so we increase the scattering, and then this is it. So we should look into this, but I think this is called Mie Scattering, right? Because it's like with sort of suspended particles that are very large, instead of like, and so, you know, this actually already might be enough. So you can kind of see the water getting cloudy. Okay.
Is it warm water? Cause
So,
And you can use the artificial coffee creamer, or just half and half works as well.
let's see. Does the light look reddish coming out that end?
Take a look through the creamer.
not particularly.
No. Okay, so that means we got to put more coffee creamer. Let's try. Hold on. Let's try this.
I was gonna say, I bet that light has an interesting spectrum. It's quite bluish.
Is bluish? Yeah. See,
Well,
that's.
LEDs tend to be more on the blue side.
They are. I think that's the case.
Actually, this is so. This is kind of cool. Take a look at that. That's a neat effect.
Oh, the watching the light go.
Yeah. Okay.
Here, turn it sideways and show them what you were laughing at real quick.
Okay.
You can see the cone of the light, which is pretty cool.
You know, actually, I think we can show one thing here already. If you shine the light through there, so shine the light through there, and then if you look out the sides, I don't know if this is going to show up on camera, but basically the scattered light is polarized. Actually, so here, Mike, you turn it, and you'll see the light coming out the sides is actually polarized slightly. So, and actually make sure that, so, okay, there's the light. Now turn.
I can't really see the effect, to be honest.
No. Well, look at it with your eye.
Oh, yeah, that's... No.
No?
Well. Yes, it is. Very slightly.
Yeah, so it's not
Very, very slightly.
So that's the thing. It might not get picked up by the camera.
Yeah, if you can see it on camera right now, this is the darkest it is, and it's going to get lighter as we go this way, and then it's going to go back to darker.
Because the scattered light is polarized.
Yeah. So, hopefully you can catch that. It's very, very slight.
Okay, so let's
More creamer.
more creamer. I have to do it like slowly though, because if you do it too much, it gets too opaque. Let's see. Let's do this. Let's turn it this way, and actually, I think you should start to see at least like in. Yeah. So here, Mike.
All right, let me see if we can get that. So there you go. It's not gonna roll.
Take a look. So
Oh yeah.
it's like kind of like a red. It's not okay. It's not sunset. I mean, it's not exactly the same effect. And actually, let me see if the polarization thing works a little bit better from this angle. Huh?
It's.
You can.
Can you see?
Here.
I saw it. It's like.
It's It's not. But yeah. Look at the
So-
side, because any of those lights scattered out the
Let's
side.
see if we can.
Is that going to give us a red sunset effect? A little bit.
Slightly. Can you pull the light on the side and so we can see if it's polarized on the camera?
What now?
Pull the light source to the side and let's see if we can. Shine it in the side. So we'll see if we can.
Okay, I see.
Oh, that is really slight.
Okay, so let's continue making our sunset red though. That's I think this is
More creamer.
more. Okay, so Mike, you look and see like when.
When we have the optimal amount of creamer inside, Mike, let us know.
I will.
Okay.
It looks good. It's nice and orange.
Yeah, that's about all you're gonna.
Yeah, I don't think we're gonna get much more than this.
Oh, this maybe I put too much.
You're almost to the point of.
No more creamer.
No, she's full. That's pretty dark. Right
Oh, that's now you can't see anything. Yeah.
But
so,
the plexiglass glows.
now let's see if the scattering effect is greater. No, not really.
That's all right though. Hopefully everyone can get the idea of why the sunset looks the way it does.
Oh, you know what? Here, let's try this one. Let's try like this, and it's kind of orangey.
It is.
Oh, there you go.
There's our sun.
That actually the camera looks better.
It does look better than the.
It actually looks like an orange sunset.
Now, what about this side with being blue? Can you see that as well?
Yeah, it's like bluish and but
I can't. It's hard to tell.
it's like more like milky. You know, here let's try another thing.
It's like creamer looking.
Yeah, let's try this. No, that actually still looks blue.
It's like Dan said, it's the LED because of the way the light is coming from it.
They're getting better with the LEDs. They're getting more and more white, but they're still.
Here.
Yeah.
Try to check the polarization out now. Or still not good.
No, it's not good at all. You can see it. So if you can see it on the camera, should be getting slightly. There you go. Slightly darker to brighter as we turn, and then going back to darker. So you can see it.
All right. Well, this was probably the worst of the
The worst of the experiments we did today.
Yeah.
But that's all right.
And we will edit this to make sure it's amazing.
Yeah. We'll just add effects.
On the camera, actually, the red sunset did look pretty good.